Hello and welcome back to the refrigerator YouTube video on the basal ganglia. Let's finish up now by talking about the indirect pathway. And I love the indirect pathway because of its name. Alright, the indirect pathway inhibits movement. That is the whole goal. And just remember, indirect, IN, inhibits, IN, movement. That is the entire goal of this pathway. And just keeping that in mind, that key concept that this whole pathway is going to inhibit movement, that is the basis to understanding it. Okay, so let's go down and we got to introduce two new players, okay? And remember, the whole theme of this pathway is to decrease movement. Okay, so let's start down here with our two new players, the globus pallidus externus, subthalamus, and the globus pallidus internus. Okay, for right now, ignore this right here. Just focus on the subthalamus and the globus pallidus internus, okay? So I like to think of the subthalamus as kind of the emergency brake, and I like to think of the globus pallidus internus as a brake. So imagine you're driving down your car, and then you hit the brake. That's the globus pallidus internus. It's stopping the movement, okay? However, the subthalamus is like stopping, putting your foot on the brake, and boom, throwing in that emergency brake. You are really inhibiting movement, okay? And you can see that here because the subthalamus releases glutamate onto the globus pallidus internus and really gets the globus pallidus internus going. So I like to think of the globus pallidus internus as a brake with your foot, and I like to think of the subthalamus as an emergency brake to really stop that car, to really stop that movement. Okay? So now, how does the globus pallidus externus fit into this picture? So let's focus right here. Well, the globus pallidus externus, as you'll see, is in green, which means it excites movement. Okay? So I like to think about the globus pallidus externus as externally removing that emergency brake, okay? And it's in green because it excites movement and it removes the emergency brake, which is the subthalamus. And how does it do that? Well, how do you get rid of emergency brake? You take it off. And how does it do that? It uses GABA to inhibit the subthalamus, aka the emergency brake, allowing more movement. Okay? All right. I hope that makes sense. Let's go back up and let's start down with our whole pathway. We're going to first look at how the cortex is involved, then acetylcholine, then dopamine to finish this out, okay? And then at the very end of this, we're going to have a nice overview of the pathways and kind of a succinct manner. Okay, let's start back up here with glutamate. So cortex, it releases glutamate, and remember, the whole pathway is inhibitory. It's inhibiting movement, okay? But we're going to look here at the individual neurotransmitter level, which is different, okay? So the cortex is going to release glutamate, okay? It's going to bind to the putamen cells. Okay? And glutamate by itself is an excitatory neurotransmitter. So it's going to get the putamen all excited. It's going to get it going. It's going to get the putamen all excited. And when the putamen's excited, remember, it's going to release GABA. Just like about every other neuron in this pathway. It's going to release GABA. And what is GABA? GABA is an inhibitory neuron. Okay? So what are we going to do with GABA? GABA is going to get sprinkled all over the globus pallidus externus. And it's going to basically take out that pathway. Okay? And why does that make sense? Well, remember, the globus pallidus internus is in green. It's promoting movement, and by inhibiting it, we are removing something that removes our emergency brake. So I like to think of this as just get rid of the globus pallidus externus, which is inhibiting our subthalamus. Remember, the subthalamus is emergency brake, so I like to think of the putamen coming online. It releases GABA, which gets rid of our globus pallidus externus and allows us to, wham, throw in that emergency brake with the subthalamus, which then releases glutamate onto the globus pallidus internus, wham, another brake, sprinkling all kinds of GABA all over the thalamus. Just sprinkling tons of it. We're not going to get any movement then. Okay? And that's the way I like to think of this pathway. Okay, now, in this pathway, if we're inhibiting movement, what neurotransmitter do you think is more important for inhibiting movement in this pathway? Dopamine or acetylcholine? Well, remember, acetylcholine's always been in red. It always inhibits movement, no matter the pathway. And dopamine's always in green. Remember, it's the gasoline that fuels our movement. Okay? So how does acetylcholine inhibit movement in the indirect pathway? Well, remember, acetylcholine is released by those interneurons, which surround the putamen, those cholinergic neurons, and they go ahead and they release acetylcholine, which is here in red. And what does that do? Well, if we want to inhibit movement, we really got to get the inhibitory pathway going. Okay? And how do we do that? We really get the putamen going. We really get it excited. So acetylcholine works in conjugation with the cortex and really gets the putamen going. The putamen releases even more massive amounts of GABA, and boom, we are really knocking out the globus pallidus externus, which is in green because it promotes movement. And by really releasing acetylcholine it really allows the putamen to release GABA from the putamen, and it really knocks out this player, allowing the subthalamus, boom, that emergency brake to get thrown into place, and boom, it allows us to get the globus pallidus interns going, and boom, to take out the thalamus, therefore we don't get movement. Okay, now we have one last player to get into this pathway, and that is dopamine, all right? So let me go here and erase some of this, all right? We're not as fancy as Boards and Beyond here, or maybe even Pathoma, but you know what? We do our best with our visual appearance, and so if I have to use a finger eraser, I have to use a finger eraser, just how it works. All right, so everything's in place, all right? Now let's add back into that. Okay, so we've already talked about glutamate, we've talked about acetylcholine, let's add in dopamine, all right? And specifically when we're talking about dopamine, we have to be talking about the D2 receptor. Okay, and how do I remember the D2 receptor, which would be right here on this putamen cell? How do I know that that is the important receptor? Well, remember with direct, we had that many letters. With indirect, we added 2 more letters on. So I just like to think of D2 getting those 2 more letters in there. Okay? So that's how I think of it. And basically, now you really have to think about the physiology here, because the D2 receptor, okay, it receives the neurotransmitter dopamine from the substantia nigra pars compacta. Remember, that's our gas station. It's going to release dopamine onto the D2 receptor. Okay, now this is where you really have to think about the physiology. What is our main goal of dopamine, no matter the pathway? It is to always get the movement going. It is always the fuel. The substantia nigra pars compacta is the gas station. Dopamine is the fuel. We got to get the pathway of movement going, of movement. Now, but let's think about this. We're in the indirect pathway, which inhibits movement. So, what do we have to do? We have to inhibit the indirect pathway. It's addition by subtraction. It's having negative influences in your life, and you're removing those negative influences. And how do we do that? These D2 receptors are inhibitory. Okay? And they basically knock the putamen offline. Get rid of that putamen. Okay? And this allows our new guy right here, the globus pallidus externus, he gets going, he increases in activity because we've removed that inhibition, and now he removes that emergency brake. Boom, we're going to sprinkle GABA down here on the subthalamus, get rid of the subthalamus, then we get rid of the amplification of the globus pallidus internus, and boom, we get more of the thalamus projecting to the cortex, exciting our cortex. And really, a bottom line of this is you can kind of think about it as, you know, once the D2 binds here, you can think about the D2 receptors basically leading to more activation or less inhibition of the globus pallidus externus, which allows the thalamus to increase its activity. And don't confuse this with a neuronal input to the thalamus. It's just to show you that these motor systems, the globus pallidus externus, increases movement as shown by the green. Okay? Isn't that beautiful? It's a complicated system, and you have to really think about the neurotransmitters. But I think if you keep these 2 big ideas in mind that we're going to review on the next bottom of this refrigerator, I think we'll be able to score quite well on this. All right, so let's move down to the bottom of the refrigerator. Look how much we've processed from in 1 year. Now we get to use even the bottom of it. All right, and my cat wanted to join the video. Hi, Penny. All right, so we got to start here with the direct, okay? So, I'm sorry, let's start with the indirect, all right? Okay, so when thinking about, we're just going to look at the direct, indirect, and these are basically, you can think of this as the neurotransmitter takeaway, okay? These are kind of the neurotransmitter takeaway from each of the pathways. So in the indirect, which we just saw up here, we saw that the cortex, when it releases glutamate, in conjunction with acetylcholine, ultimately leads to decreased movement. They both activate the indirect pathway, which inhibits movement. The converse is also true. The D2 receptor, when dopamine binds it, inhibits this pathway to increase movement. Okay? Now, in comparison to the direct pathway, okay, over here, the cortex released glutamate, and along with the D1 receptor with dopamine, increased movement, and acetylcholine inhibited this pathway to decrease movement. Okay? And basically, one other big takeaway is the D1 receptor in the direct pathway is excitatory, and it excites this pathway, which is all about movement, exciting movement. That's why it's in green. And the converse, the D2 receptor is inhibitory, and basically it's inhibiting the indirect pathway, which inhibits movement, therefore increasing movement. All right, y'all, it's been fun walking through this. I hope this helps. It's very complex. It takes a lot of time, and I wish us all the best of luck with it. All right, it's been fun. We'll see you in the next Refrigerator YouTube video.